All right, so we are going to do section 721, day one. It's not labeled that way. It's basically just the front and back of the paper, but I split it up, so you only had the front today. So 749, it says Carla is thinking about parallelograms and wondering if there are as many special properties for parallelograms as there are for triangles. She remembers that it is possible to create shapes that look like a parallelogram by rotating a triangle about the midpoint of one of its sides. So looking at the part A, it says carefully trace the triangle to the right on tracing paper. You're not going to do that today just because it's a lot with me out. So I'm just going to show you what this will look like. In the end, it says be sure to copy the angle markings as well, then rotate the triangle about a midpoint of a side. So we've done this a long time ago, I think in like chapter 1, where we actually took physical triangles from, I think it was the Shape Factory, and put them on poster paper. So the midpoint of the side is right here, and we're rotating about that. So mine's not going to look perfect, but it's going to end up like this. And then I'm going to copy down all of the angle measures that were on there that they wrote. So then it says, what is a parallelogram by definition? So this is something that we're going to talk about a lot, and you're going to get a toolkit. But a parallelogram by definition is a quadrilateral, so that's a four-sided figure. With two sets of parallel sides. Okay, so now that we have our copied rotated triangle and our definition, we're going to read some questions here. Part B, it says, is Carla's shape truly a parallelogram? Use the angles to convince your team that the opposite sides must be parallel, then write a convincing argument. So we need to think about what kinds of congruent angles, because there's a lot of congruent angles in this picture, will give us parallel lines. So I'm going to just act like in my head I've got a set of parallel lines. So let's just say that these were parallel. Oh, that is really thick. Hold on. Let's see that this one still very thick. Sorry guys, I don't use this a lot. Oh goodness. That this is parallel to this. So then here's my transversal. So I've got this situation going on, and we've dealt with this a lot. That would be considered alternate interior. And then if I look at them, I have this here, and I had this here. So I just copied down what I had. I didn't actually write that they were the same, just because. So those are actually the same, which is great. So we know that if alternate interior angles are congruent, then parallel. But that only gives us the top and the bottom parallel to each other. So now, let's see here. I don't think I'm going to be able to move the parallels, so I'm going to have to write over it. Now we got to check the other side. So I'm talking about the left and the right. So then we have this situation going on, where it's like kind of a moved Z. And this top one and this one, those are my alternate interiors, and those are actually also the same based on the picture, not that I just randomly drew it to make it work. So we know that for both situations, if alternate interior angles are congruent, then parallel, and that gets us our two sets of parallel sides. So yes, that is in fact definitely a parallelogram. So we're good on that. Okay. Next part, it says, what else can the congruent triangles tell you about a parallelogram? Look for any relationships you can find between angles and sides of a parallelogram. So there's lots of different things to think about, but if I'm thinking about just a whole parallelogram itself, I know that looking back up at our picture, that these sides are equal based on the fact that it was rotated, those two triangles, and then these sides are equal. So not only are opposite sides parallel, we also know that opposite sides are congruent. So I'm going to draw a quick picture of that and then write that down. And then another thing that we can talk about is opposite angles being congruent. So these ones are definitely easy to see that these are congruent, but then when I add these together, those might be just a little bit harder to tell that they are congruent to the ones across from them because you add them together. So I'm going to draw a picture to make that a little bit easier to see. So these are equal and these are equal. So I'm going to say opposite angles are congruent. And again, we'll be putting these things on the toolkit when I'm coming back. So part D, it says, does this work for all parallelograms? So this worked in this special situation up here for this parallelogram, but is it generalized to everything? That is, does the diagonal of a parallelogram always split the shape into two congruent triangles? So just a heads up, diagonal, here is a quick pic of what a diagonal is. It's just connecting opposite corners here, like that. So I'm going to run an arrow if you need that visual, because we're going to have lots of, new words and things to remember. So let me read that again. That is, does the diagonal of a parallelogram always split the shape into two congruent triangles? So if I look back up here, this diagonal right here was splitting the shape into two congruent triangles because I rotated, but does it just do it anyways? Knowing only the opposite sides of a parallelogram are parallel, create a flowchart to show the triangles are congruent. So this is kind of the format you're going to be seeing now for flowcharts. It's kind of beefed up. There's more circles. Notice on the top where it says given prove. That is new. And I'll be giving you pointers and ways to deal with these things. We're always going to kind of go back to what we know. So we are used to our 3 leading to 1. So that is going to be in this location right here. So we are very familiar with that. We know that these have to be sides and angles that are congruent, and the final one has to be triangles that are congruent. So that is kind of our home base. Some other things that you'll be dealing with here are given is always going at the top and prove is always going at the bottom. So we are going to throw the prove at the bottom, which is something that we already know. So we're trying to prove that the triangle ADB is congruent to a triangle CBD. So we'll throw that down there. Triangle ADB is congruent to triangle CBD. And we don't know why yet, but we definitely know that that is useful info that we are going to put down there. So now the next piece is we got to deal with the given information to help us lead to those triangles being congruent. So it says opposite sides of a parallelogram are parallel. That's not normally how we put things in bubbles. We normally put specific letters. So if we look at our picture, it's telling us some parallel sides. So let's deal with that. So let's use a different color here. It's saying that these are parallel, AB and DC, and that's taken care of right here. So that's actually given based on that sentence, that those are parallel. And then we need another set of parallels. So let's do the other set, AD and BC. So I'm going to put that as my other given, which this says given right here. So I'm going to put that in this bubble. So we did all the scary stuff, all the new scary stuff of our extra bubbles. Yes, there will be different situations with more bubbles. Yes, we'll talk about all of that. But here we basically did it. So now we're going to utilize those pieces to get us our familiar congruent triangles to get to the end where we're trying to say that that the triangles are congruent, which tell us lots of important pieces about a parallelogram. So looking at this picture now, I'm going to utilize the AD and BC in that first bubble to help us prove some other things. So AD and BC, we know we can make that weird little Z shape like this, and we know that if parallel, then alternate interior angles are congruent. So that would be these angles right here. So I'm going to take those angles and write them down. And I just decided to put in my first bubble, but you can put them in any of them. So I'm going to say angle ADB is congruent to angle CBD. And again, we do have to use three letters, like the past, because there's like a lot of lines there. So it wouldn't be easy to just say, hey, D equals B, and you'd be like, oh, there's like a lot of those. So we are going to write a sentence underneath real quick to represent why we know that's true, because it's not given. The parallel lines up here told us those were true. So we're going to lead from that circle down, and then we're going to say if parallel. And remember, you can write this sentence however you want. You just have to include the important details. If parallel, then alternate interior angles are congruent. So then that's actually what's going to happen in this next one, but just another set. So here is our parallels again. Here's our transversals. So sorry, it's hard to see. It looks like that. We're going to talk about these angles. Writing that Z is really helpful. So then I'm going to do that same kind of setup in the next bubble. So there's kind of already a template over to the left. So angle ABD is congruent to angle CDB. And just as a reminder, if you're struggling with writing angles with three letters, you are going to kind of like connect the dots to create that angle. So I'm going to run along from A to B to D and see if that's actually creating this angle right here that I wanted. And then the reason for that being true is if parallel, then alternate interior angles are congruent. Excuse my handwriting. So now in our picture, if I kind of clear this up and show you what's going on. Here, let me make sure I got it. Okay, we got 2 and then 1. So this is what I have so far. I've got some angles in there. We know that for congruence, you need at least one set of sides. You can't just have angles. So looking at those triangles, this middle side is the same. And we want to be careful about the order of our letters. So BD in this first triangle actually matches up with DB in the other one. So BD is congruent to DB. And then remember, all of these symbols of how to like write angles and sides are all written on that poster on the wall. That's not going to move. So if you ever need to reference that, you can. And then we know that those sides are equal because they're attached. So parallel lines are not saying that those are the same. So what I'm trying to get at here is you would not write any arrows between those things because they are not related. Just because lines are parallel does not tell me anything about those sides being connected like that. So the actual reason for those being the same is called reflexive, and we've done that before. And then the last piece here is to say, okay, these three things lead to the triangles being congruent. That's what we were trying to prove. That would go at the very end. And then our reason for that is based on the picture. So that would be angle, side, angle. And then don't forget to write congruence. So you are done for today. You can just take the rest of the period as a study hall. Make sure that you are turning this paper into the turn in bin for your class period. Okay, have a good day.